In this lesson today, it's kind of an extension of yesterday's lesson. So if you're in my class, we're not taking additional notes, but we're just taking it a step farther than we did yesterday. So we're going to be looking at rational exponents and how to evaluate them. So we're learning how to simplify these. Okay, so first what we have here is we have the cubed root of x times y, both raised to the 9th power. Now, if you remember yesterday, we talked about how if you have a base such as 25 and it's raised to an exponent that's a fraction, the denominator is the root. It becomes the number outside the radical sign. So that's the square root of 25 raised to the 1st power. We can actually do this in reverse. So if you look up here at this one, inside the radical sign, underneath the radical sign, we have x and y raised to the 9th power. Because x and y is in parentheses, the 9th power is applied to both of them. So what we really have underneath is x to the 9th power and y to the 9th power. Now, if we take each one separately, we could break this down even farther. We have the cubed root of x to the 9th power, and we have the cubed root of y to the 9th power. You can take them separately because we have two different bases. Now, if we did what we did yesterday in reverse, we know that this is the root. The root is the denominator. The root is on the bottom of a plant, so it's at the bottom of our fraction. And remember that our exponent is our numerator. So what we really have here is x raised to the 9/3 power. This was the root. The numerator is the exponent. Now, so all we have to do is divide. 9 divided by 3 is 3. So all you had to do is look up here and know that I have to divide 9 divided by 3 and get 3. Same thing with the y. This is the root. This is the numerator. So we have y raised to the 9/3 power. 9 divided by 3 is 3. So we have x cubed, y cubed. So we're kind of going reverse from what we did yesterday. Today we're starting with it written with the radical sign. And yesterday we started it with an exponent and changed it into that. All right, so look at this. We have the 5th root of x, the square root of x, and then times. Notice that there's no symbol in there to tell us what to do, so it's an understood multiplication. So remember that 5 is the root. So what is the exponent that's attached to the variable x? When there's no exponent visible, we understand it to be an invisible 1. So our root is 5, our exponent is 1, so to rewrite that with a rational exponent, it would be x to the 1/5 power. If you move to the next one, remember, if you do not have a number right here indicating what the root is, it's an understood square root. So the root here is 2. Again, we have an invisible number here, and we know it's going to be 1. So both of those numbers happen to be invisible, but they're just understood. So since this is the square root of x to the 1st power, we can rewrite that as x to the 1/2 power. This becomes the root, the denominator. The exponent becomes the numerator. Now, we have learned that when we have the same bases, the x is the same base, and they're being multiplied, we actually add the exponent. Well, adding with fractions, you have to have a common denominator. And a common denominator with 5 and 2 would be 10, so we're going to rewrite this with common denominators. Since we have to add our exponents, that would be 2/10 and 5/10. Now we simply add the exponents, so that would be x to the 7/10 power. Erase this, so I could have just gone through the PowerPoint with doing it. There's the 1/5. We actually add. There's the exponents, adding. Okay, let's look at this one. Okay, break it down step by step. First, we're going to look at just this portion. Outside, we have an exponent. It's going to be applied to each base inside. So what we have first is x squared raised to the 2nd power. And then we have y squared. Remember, with an exponent raised to an exponent, we call that power of powers, and we multiply it. So x squared raised to the second power would be x to the fourth power. Here we just have y squared. Now let's look at the next portion. Okay, we're going to rewrite this again. Remember, this is the root. This will be the numerator on top. So we would rewrite that as y, 4 for the root from here. I know they're the same number, but you need to know where they come from. And this would be the numerator. Well, 4 divided by 4 is 1, so we just have y to the first power. Now, if you're multiplying all of these, remember, if you have the same bases, then we can combine them together. We combine the same bases by adding the exponent, because here we have y times y for y squared. Here we have 1y, and if we were going to multiply all those together, y times y times y, there's three of them. So that would be y to the third power. We just added the exponents, and we still had x to the fourth power. So our final answer is x to the fourth power y cubed. Okay, let's look at the next one. Here's just a review of what we just did. Okay, so here we have 8x to the ninth power raised to the 2/3 power. Okay, so we're going to take our exponent and we're going to apply it to each base. So that means we have 8 to the 2/3 power, and we have x to the ninth raised to the 2/3 power. Again, we have this scenario where there's the root. The root is on the bottom of a plant. The root is on the bottom of the fraction. So when we rewrite that, we would say the cubed root of 8. And once we find that out, we are going to square it. What number multiplies times itself 3 times to get 8? That would be 2 times 2 times 2 equals 8. So the cubed root of 8 is 2. And when we square it, we get 4. Let's look at the next one. When we have an exponent raised to an exponent, we actually multiply them. So we have 9 times 2/3. We can do our cross canceling, and we would find that that would be 6. So we have x raised to the 6th power. And we just bring that down because it's simplified. So we have 4x to the 4th, or 4x to the 6th power. Again, if you want to see that with the PowerPoint, there's applying the exponent to each of the bases. And then where we take the cubed root of 8 and then square it would be 4, and then x to the 6th power. Okay, let's look at this one. Again, we have an exponent outside. Inside the parentheses, we have 2 bases, so we have to apply that exponent to both of the bases. So first we have 64 to the 1/6 power, and we have x to the 12th raised to the 1/6 power. So here's our root. So that means we want the 6th root of 64. And when we raise that to the first power, nothing's going to change. So what number multiplies times itself 6 times to get 64? 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6. 2 times 2 is 4. 8, 16, 32, 64. So the 6th root of 64 would just be 2. And 2 raised to the first power is still 2. If we look over here, we have x to the 12th power raised to the 1/6 power. If we multiply 12 times 1/6, you're going to get 12 divided by 6, which of course is 2. So we simply have x squared. And that's your final answer. Let me erase all this so you can see this again if you want it in review. I hope that helps just to take what we learned yesterday and to just add some more practice to it.